Vanakkam. Welcome to this course on biomedical instrumentation. We were looking at electroretinogram. Let us discuss some of the common beliefs or common student misconceptions, some of the ideas that students may not completely understand regarding the electroretinogram. First is, sometimes students think that ERG essentially measures vision. This is not true. ERG is essentially a measure of retinal function, not vision itself. Okay. Second, higher ERG means better vision. This is not true, because sometimes higher ERG is possible in some diseases. Okay. So, higher amplitude of ERG does not necessarily mean that it is actually better. ERG requires pupil dilation. Not always true. Depending on the protocol and depending on the study of interest, it may or may not require pupil dilation. Fourth, corneal electrodes are painful. If we give proper anesthesia, then the pain may be managed. Something to keep in mind. Corneal electrodes, recall, these are silver chloride electrodes placed in a contact lens and placed on the cornea. Okay. What is the impedance of these electrodes? We discussed this, about 5 kilo ohms. We discussed this. Okay. The other belief is that normal ERG means normal eye function. This is actually not true, because in full field ERG you may not get localized dysfunction, which is why we discuss several configurations, several possibilities. One is having full field ERG, the other is having multiple individual level ERG, which we then superimpose one on top of another, because we want to take advantage of the linearity principle and we will have to average across several exposures, several trials. This is something that we discussed. Anyhow, continuing on this line, but in a different topic, in this video we will look at electrooculography, and in electrooculography we will look at unipolar configuration, bipolar configuration and RPE assessment. This is critical, retinal pigment epithelium assessment, and the critical significance of this ratio called as Arden ratio. We will look at all these topics in this video. So, the eye actually maintains a steady potential difference. It is a biological battery that maintains a steady potential difference between the cornea and the retina. Now, this corneo-retinal potential, CRP. This corneo-retinal potential is approximately 1 millivolt, actually little less than 1 millivolt. It is about 0.5 to or rather 0.4 to 1 millivolt approximately. Now, that means that the eye can be modeled as an electric dipole that is placed within a volume conductor. What is a volume conductor in this case? The head and the entire neural structure within the head is the volume conductor. And the movement of the eye, depending on the movement of the eye, that means the cornea moves, the direction of the dipole will change. Note that this is a 3D motion. So, that means the eye can move in the horizontal direction like this and in the vertical direction like this. So, it is a 3D motion like that. It can do that as well as that, and a combination of these, it can do that. Our interest is in picking up these movements. Note critically that EOG does not measure movements, rather it measures the electrical activity, rather it measures the electric dipole and its direction. That is what is measured, not the muscle movements. There is a difference. Muscle movements means it is somewhat similar to EMG, but that is not what is happening here. EOG essentially measures the activity of the electric dipole, that corneoretinal potential. Now, how is this corneoretinal potential maintained? Because of these specific active mechanisms such as the potassium pump and the chloride pump, and a combination of several other active mechanisms such as the sodium potassium pump that we discussed previously. There are other such active mechanisms that maintain this corneoretinal potential. So, as the biopotential, remember that this whole movement of the dipole is happening within the volume conductor, that is the head. So, that means when you are picking up signal from the surface, from outside, you are going to have these volume conductor effects. Like in EEG, where we discuss the volume conductor effect, there is going to be quite a bit of volume conductor and its effect that is going to be there. That means that your localization, your ability to localize is going to be quite compromised, is going to be at least somewhat compromised. Now, that is that. Now, how could you compare this? How could you visualize this? So, this is similar to having a compass in the Earth's magnetic field. To pick up the particular direction, you could essentially use a magnetometer to detect changes in the field, something like that. So, this is the compass is moving as the similar to the movement of the eye, or rather the eye is moving similar to the movement of the compass. To get the direction of the compass, you need to find a way to calibrate and find where the compass is pointing to using a magnetometer. Something similar to that is what is happening. This dipole, the electric dipole is moving. Recall that this is not actually the muscle movements, but rather the movement of the electric dipole itself that we are interested in. Okay. So, this is the biopotential recording that is generated by the movement of the eyeball, but essentially dipole movements, something to keep in mind. It is not the muscle activity. These are picked up by the small surface electrodes similar to EMG electrodes. So, you place one pair of electrodes above and below the eye to pick up the potentials that correspond to movement of the vertical movements of the eyeball, to measure these movements, okay, this, so that one and that one for example. And to pick up these, you have another pair of electrodes that are placed to the left and right of the, another pair of electrodes that are placed to the left and right of the eye to pick up the horizontal movement. And you center a recording pen similar to EEG and ECG, you center a recording pen on a recording paper corresponding to the potential changes, right. So, it is less widely used in clinical purposes. It usually is a complement for ERG and other visual complements, ERG and other visual measures, but is not used as a standalone test by itself, something to keep in mind. So, the eye rotation essentially moves the ocular or the dipole, electric dipole of the eye relative to the stationary orbital electrodes. So, note that in the corneoretinal potential, cornea is positive. So, if you are looking left gaze, if you are looking on the left side with the left eye, the cornea approaches the electrode near the canthus and the recorded potential is a negative trending change. With the left eye you are looking at to the right side, then the cornea approaches the electrode near the inner canthus, not the outer canthus. In the previous case it was the outer canthus, in this case this is the inner canthus, that is reflected as a positive recorded change. So, the angle of gaze is essentially proportional to the EOG signal. Here are some examples of the EOG signals that are shown. Note that between participants there will be a variation in the amplitude of EOG, like in the case of EEG, and between sessions for the same participant also it is possible to have a variation in the EOG amplitude. So, that means that you need calibration even for the same subject, even for the same participant between sessions. So, that means it requires quite a bit of calibration in this. There are two ways, two configurations in which you could measure EOG. One is the unipolar configuration, in which you measure the potential of a single electrode with respect to a distant electrically active reference electrode, some electrically inactive reference electrode somewhere else. The active electrode is placed near the eye, maybe at the outer canthus or the inner canthus, and the reference electrode is a distant electrode, maybe placed on the mastoid earlobe or the forehead, and the ground electrode is placed on the forehead or mastoid. This is less commonly used for routine eye movement tracking compared to bipolar EOG, but more frequently this is used in research context or specialized research context, where you have an interest in identifying absolute potential changes, the changes in potential at a particular point of interest, at a particular location of interest with respect to a broad reference. Now, quite often we use this as a way to identify eye movements while processing EEG signals. Let us say you are interested in measuring EEG and you are interested in finding out where eye movements, eye blinks and other artifacts from the viewpoint of EEG, these eye movements or artifacts are happening. If you are interested in identifying that, then quite often EOG signal is used as the input to identify when eye movements are happening, so that you could adjust the signal processing in EEG accordingly. Okay. Of course, being unipolar, this is more susceptible to noise because you are not going to have the differential amplification. That means that there is going to be poor common mode rejection. So, this common mode interference will still be there, but note that this has its own application. So, it is used in research and in specialized applications. In bipolar mode, you essentially measure the difference, potential difference between two active electrodes and you amplify that. So, in the horizontal eye movements, there are two active electrodes present on the outer canthus of each eye. In the vertical movements, electrodes are placed one above and one below the eye, right. You use a common reference electrode, usually placed at some neutral site such as the earlobe or forehead or somewhere, with a ground electrode on the forehead or the mastoid process. So, this method, this configuration of using it in the bipolar configuration is the standard technique or the standard method for clinical electrooculography, specifically for measuring eye movements or kinematics. And the retinal pigment epithelium, that is standing potential, used, that is measured using the Arden ratio. We will look at what this is in the next few slides. So, this retinal pigment epithelium and its function is critical for proper eye function. So, it is critical to have a measure of the functioning of the retinal pigmental epithelium. Being bipolar, essentially there is going to be an excellent common mode noise characteristics. So, that is, it is going to be able to reject most of the common mode noise and essentially provides a robust and excellent differential signal that is proportional to the angle of gaze. And this information we have received from this ISCEV, which is I asked you to check what it is in one of the previous classes, that is essentially the International Society for Clinical Electrophysiology of Vision and the EOG standards and the general electrophysiology principles. These are the source from which we took this information. We are interested in using EOG to assess RPE or retinal pigment epithelium. It essentially is used to find health and function of the RPE. So, this EOG measurement essentially depends on the resting potential in the RPE under varying light conditions. If the patient is in darkness, then the resting potential gradually reduce, reaching a minimum point called as a dark trough, and then light is introduced. Once light is introduced, the RPE resting potential starts increasing, reaching a so called light peak. So, you have a dark trough and the light peak, and during these two motions, these two phases, the patient is required to perform some pre-discussed or some fixed amplitude movements of the eye to record the underlying potential of the dipole. Now, as the patient is doing these maneuvers with the eye, these movements with the eye, a key diagnostic index that is derived from EOG measurements, which is the Arden ratio, which is essentially the ratio of light peak voltage divided by the dark trough voltage. Typically, Arden ratio above 1.8, often 2 to 3, essentially means that there is normal RPE function. An Arden ratio below 1.8 indicates compromised retinal pigment epithelium function. It is crucial for diagnosing inherited retinal diseases affecting the retinal pigment epithelium, such as the Best disease. That is, it is not the best disease, it is the name of the disease, rather Best's vitelliform macular dystrophy, which is the disease. Note that EOG is also quite often used in diagnosis of pattern dystrophy, other problems such as pattern dystrophy. In this case, pattern dystrophy with the Y. In this case, Arden ratio is between 1.5 to 1.8. The other application is to identify the effect of toxicity of hydroxychloroquine. Recall this, recall what this is from, if you are able to recall from our COVID times. There was a time during COVID when it was believed that hydroxychloroquine or HCQ essentially can act to reduce the activity level of the immune system to address severe or very strong COVID, when the immune system is going into a panic mode. In that it's quite often HCQ is used to treat the autoimmune diseases, such as, for example, quite often this is used to treat rheumatoid arthritis and this. So, those who are taking HCQ for treatment of rheumatoid arthritis will have to get their eyes tested quite often for toxicity, and it turns out that this HCQ related toxicity will first be visible in EOG and related parameters such as Arden ratio before any visual symptom begins to occur. So, that is the other application of EOG. Okay. The other one is the retinosis pigmentosa. We have seen this. EOG is used for differential diagnosis of this disease also. So, in this video I have said that this is actually retinosis pigmentosa, this must be actually retinitis pigmentosa. Slight mistake, this is wrong, this is right, something to keep in mind. Okay. So, with this we come to the end of this video. In this video we looked at EOG, unipolar and bipolar configurations. Quite often unipolar is used along with EEG, for example, to identify movements of the eye so that appropriate signal processing adjustments can be made in EEG itself. So, that is where EEG is the primary investigation, EOG is used to identify eye movements so that you can adjust the signal processing algorithm for processing of EEG. The bipolar configuration is the standard technique for measurement of the movements itself, and Arden ratio and values below specific values below 1.8 for example are considered pathological. Yes. With this we come to the end of this video. Thank you very much for your attention.